Alright, so we are going to review a couple algebra problems and the proofs on the review, and hopefully get you guys all ready for the test tomorrow. So let's quickly talk about number one. I know we talked about this in class, but I really want to kind of refresh the idea of factoring, and especially factoring when there's a coefficient in front of the x squared. So it says in the diagram AB is congruent to AC. So again, we're going to mark what we know congruent. And remember what we talked about with the base angles theorem. If the sides of a triangle are congruent, then that means the angles across from them are congruent as well. Therefore, I can set up the equation here, 3x squared plus 7x is equal to 40. Now, it's kind of like those problems from last unit where we know we have this x squared here, so that means we're going to have to factor. And when we factor, that means we have to get everything on one side and 0 on the other side. So I'm going to take this 40 and I'm going to move it to the other side. So that's going to give me 3x squared plus 7x minus 40 equals 0. Alright, now we have to factor. So when I factor, I have to create my two sets of parentheses. When we factor, we're really talking about reverse FOIL. Okay, so I have to think what would be numbers that could go in the first part of my parentheses. Well, I'm going to have 3x here and x here, because 3x times x is going to give me 3x squared. Now I need to think of two numbers that multiply together to give me negative 40. Alright, this is where we have to kind of guess and check. We got to start thinking of some multiples of negative 40. So just off the top of my head, we have negative 5 and 8. We have negative 10 and 4, and then obviously the other way around, negative 4 and 10. 20 and negative 2. So just kind of start by thinking, what are some multiples of 40? Okay, so we have negative 5 and 8. We also have negative 8 and positive 5. And what you have to do here is kind of just, it really turns into a guess and check. Well, what happens if I plug in negative 8 here and positive 5 here? If I FOIL that out, am I going to get this? So let's mess around with it. So if I do 3x times x, I'm going to get 3x squared. Outside, 3x times 5 is 15x. Inside, negative 8 times x is negative 8x. And then last, negative 8 times 5 gives me that negative 40. Okay, well notice this is going to give me what I originally wanted to have. So I have 15x minus 8x. That's going to give me 7x. So this is how you would factor 3x minus 8, x plus 5 equals 0. Now it turns into a problem like last chapter where I would say, okay, well, either 3x minus 8 equals 0 or x plus 5 is equal to 0. And now I can go ahead and solve for x. So I believe if I end up solving for x, I get two numbers. I get 8/3 and as well as negative 5. But make sure we remember to set up our equation correctly. Alright, let's go on to the next one here. It says, given you have two triangles. You have triangle NEW. Triangle new is congruent to triangle car. It'd be nice if I got a new car right now. So bear with me, the not so good looking triangles. I'm still getting used to this Mimeo device. So what do we have? We have triangle new and triangle car, and they're congruent. So that means that all their corresponding sides and angles are congruent. So we have to make sure that we label this correctly. That means I have to label N and C corresponding to each other. E and A have to correspond to each other, and then W and R have to correspond to each other based on the way that they're written in the congruent statement. So it tells me EN is equal to 11, AR is equal to 2x minus 4y, NW is equal to x plus y, and CA is equal to 4x plus y. Oh, it gives me more. It tells me that EW is equal to 10. Okay, so now I have to figure out what are some equations that I could write that'll help me solve this problem. It wants me to first draw the triangles, okay, so that's what I did, and then it says find CR. Well, it doesn't tell me anything for CR, so I can just write x plus y because I know CR and NW have to be the same based on the way that it's written in the congruent statement. So what do I know? Well, I know EN and AC are the same, so there's one of my equations. I could write 4x plus y equals 11. Okay, and I know that, again, everything's based on how it's written, the ordering of the letters. And then my other equation could be 10, or 2x minus 4y is equal to 10. Alright, and now what we do is we can use elimination to solve. So remember, when I use elimination, I like to line up my variables. So I'm going to line up 2x minus 4y is equal to 10. Alright, and now I'm going to multiply the top equation by 4 so I can cancel out the y's. So if I do that, I'm going to get 16x, 4 times 4 is 16x, plus 4y equals 44. 4 times 11 is 44. So now, what happens when I add my equations together? My y's cancel out, and I have 18x equals 54. And that's going to give me, when I divide 54 by 18, x is equal to 3. Alright, once I get x equals 3, now I have to go plug that back in and solve for y. So if I plug x equals 3 back in there, I'm going to get 6, because 2 times 3 is 6, minus 4y equals 10. Subtract 6 from both sides. So I get negative 4y equals 4. So that's going to give me y equals negative 1. So I have x is equal to 3, y equals negative 1, and it wants me to find CR. So that's going to be 3 plus a negative 1. So CR is equal to 2. Okay? Alright, again, if you have any questions on this, and if my explanation is not helping here, make sure you shoot me an email or come see me tomorrow before the test so I can help you guys out. Alright, let's get into the proofs now. I'm going to have to write small, and pardon me if you can't read my handwriting. Just to save space, I am going to, and again, I don't want you doing this on the test, but just to save space, I am just going to draw an arrow here for my given. Okay? Because otherwise I don't know if I'll have enough room for some of these proofs. So it's given here that I have circle O, and then I have OG is perpendicular to FH. Alright, so what is the first thing that I want to do? If I see a problem like this, and when you see a problem like this on the test tomorrow, make sure you draw in your radii. So draw in OH and OF, and that has to be a step in your proof. So I actually have to write draw OH and OF. And again, I apologize for the handwriting. Draw OH and draw OF. And how do I know that? Because I know that 2 points determine a line. 2 points, or I'm going to write 2 points make a line. Alright, just because I have a feeling my words are going to start to blend together, I'm going to do every other step as alternating colors. So I drew that in. Now, on the test tomorrow, after you draw in your radii, make sure you state that they're congruent. So I know that OH is congruent to OF. So I can write OH is congruent to OF, and that's because all radii are congruent. So I'm going to write that in there. All radii are congruent. Okay? Now, again, what are we trying to prove? We're trying to prove that FG is congruent to GH, so let's try to prove these two triangles congruent. Well, we haven't said my favorite step yet, which is the reflexive property. We know that GO is a part of both triangles, so let's write, GO is congruent to GO. I'm going to write GO is congruent to GO by the reflexive property. Alright, now there's still one piece of information in the given that we haven't used, and that's this. OG is perpendicular to FH. So let's make sure we write that in. What does that mean? Well, that means that they have right angles, or that they're right angles there. So we can actually say angle OGF, that should, or OGH, and angle OGF are right angles. Okay, and how do we know that? Well, we know that because that's what it means to be perpendicular. So you could write if perpendicular, then right angles. Now, don't forget, tomorrow on the test, just because you say that they're right angles here, you still have to add another step, and this is the step that a lot of people forget. You still have to write another step that says that they're congruent. So I actually have to write angle OGF is congruent to angle OGH. And that's because we know that all right angles are congruent. So I know it's because all right angles are congruent. Now I've stated the angle's congruent. Alright, I have one side here, and I also have the hypotenuse. So this is an instance, because I have right angles, I can use the HL theorem. So I can say that triangle OG8 or OGF is congruent to triangle OGH by the hypotenuse leg theorem. We could just call that HL, because we have right angles, and we have one leg, and we have the hypotenuse is congruent. So we can use the HL theorem. Alright, and then lastly, once we have the HL theorem, once you've proven the triangle is congruent, now we can go right to what we're trying to prove, and I can say that FG is congruent to GH by CPCTC. Right. Once you prove triangles congruent, 99% of the time, your next step is going to be CPCTC. Okay, so make sure you guys keep that in mind when you're taking this test tomorrow. Alright, let's jump to the next one. And again, because it's hard for me to write and I'm saving space, I'm just going to have the given be over there. So what does it tell me? It says triangle ABC is isosceles with base BC, and then it tells me AD bisects angle BAC. Alright, well, let's take a look here. So after the given, it doesn't give me anything congruent. It wants me to prove that AD is the median to BC. So this is where you have to understand what it means to be a median. Well, a median is a segment that goes from the vertex of the triangle and it bisects the opposite side. So ultimately what we want to prove is we want to prove that BD is congruent to CD. Once we prove that, then we've proven that AD is the median to BC. So let's get started here. What does it mean to be an isosceles triangle? Well, if it tells me that this is an isosceles triangle, then that means that I have two congruent legs. So I can actually write that. I can write AB is congruent to AC. And that is just because we have an isosceles triangle, so we could write definition of, and I'm going to abbreviate this, I'm just going to say isosceles triangle. Definition of isosceles triangle. Alright, now again, looking at this, I always like to use every part of my given. So what else do I know? Well, what does this mean? When it tells me that AD bisects angle BAC, again, not side, angle BAC, that tells me that I have two congruent angles there. So I could actually write angle BAD is congruent to angle CAD. Alright, and how do I know that? Well, it tells me in the given that they're bisected, so that's what it means to be bisect. So you could write definition of bisect. You could write something like bisect equals two congruent angles, as long as you communicate to me that you understand what the word bisect means. Okay, now we haven't even used my favorite property yet, which is anytime you have triangles like this that share a side, we could actually say that AD is congruent to AD by the reflexive property. So I'm going to write AD congruent to AD, and how do I know that? Well, I know that by the reflexive property. Okay, so now what I've done is I've proven these two triangles, or I've given myself at least enough information to prove the two triangles are congruent. So I can now say that triangle BAD is congruent to triangle CAD, and that is by side angle side. Side angle side, so I can write that down. And now, again, this goes back to the beginning. What does it mean for AD to be the median for BC? Well, that means that BD has to be congruent to DC. So do we know that? Well, because we've proven the triangle's congruent, now we can say that BD is congruent to DC by corresponding parts of congruent triangles congruent, or CPCTC. So because I've proven that BD is congruent to DC, now I can say that AD is the median to BC. Okay, so I'm going to write AD as median. And how do I know that? Because I know that the median bisects opposite sides of the triangle. So you could write definition of median, or you could write median bisects opposite sides, or opposite side, excuse me, of triangle. Okay? I want to say questions, but there's no one here to answer the questions, so I guess we'll just move on to number 5. Alright, so let's go on to number 5 here. What do I got? Okay. Well, I guess I have the wrong... Oh yeah, I put the wrong order. Let's go here. Number 5. Alright, so this is a tough one because I have triangles within triangles here. So I got a lot of given information. So let's go. I'm going to go ahead and mark the given. So it tells me angle 1 is supplementary to angle 2. ME is congruent to MI. It tells me R is the midpoint of EI. And it tells me that SM is congruent to MO. Alright, so what I want to do here is I want to think about, again, what I'm trying to prove. Alright, I'm trying to prove that R is the midpoint of SO. In order for me to prove that R is the midpoint of SO, I would have to prove that SR and OR are the same. Now notice that SR and OR, okay, I'm going to try to do this as legibly as I can, SR and OR are both parts of this triangle right here and this triangle right here. So when I want to, so what I'm ultimately going to want to prove is that these two outer triangles are congruent to each other, or these two bigger triangles. We'll refer to them in this problem as the red triangle. However, before I can do that, I'm going to have to show that these two inner triangles are congruent. We'll call them the blue triangles. Alright, I kind of covered up angle 1 and angle 2 there, so I hope you see where they are. This is angle 1 and this is angle 2. Alright, so let's first keep our focus on proving that the blue triangles are congruent, and that'll help us show that eventually the red triangles are congruent to each other. And this is what we call a detour proof. I hope I have enough room. We'll see. Alright, so I have the given written down. Now, based on what else is given to me in the given, it tells me here that R is the midpoint of EI. Well, what does that mean? That means that if R is the midpoint of EI, that means that ER is congruent to IR. And how do I know that? Well, because that's what it means to be a midpoint. So I can write here just definition of midpoint. definition of midpoint. So I know that ER and RI are congruent to each other. Now, what else do I know based on the given? I know SM is congruent to MO and ME is congruent to MI, which I've labeled. Now, what else do I know about this blue triangle? Well, if I look at the blue triangle, I still have my favorite property, which is that MR is congruent to MR. And how do I know that? Well, I know that by the reflexive property. So I'm going to go ahead and I'm going to mark that down. 1, 2, 3, 4. So now, if you can see, I've actually already proven these two blue triangles congruent to each other. So I'm going to say triangle MRE is congruent to triangle MRI by side, side, side. Side, side, side. So I'm just going to say S, S, S. So side, side, side. Alright, now the reason I do that, okay, and the reason that I prove these two blue triangles congruent is because I ultimately want to prove the red triangles congruent. Well, how does that help me? How does that help me? Well, what I like to do is I like to look at the blue triangle and think, what is an angle in the blue triangle that's also an angle in the red triangle? Now, I know I covered it up, but this is angle 1 and angle 2 here, and those are both a part of the blue triangle and the red triangle. And because they're a part of the blue triangle, I can say angle 1 is congruent to angle 2 by CP, CT, C, because angle 1 and angle 2 are both part of the triangles that I proved congruent. Now, again, I must preface this, and I should have said this at the beginning, there's multiple ways to do some of these proofs. So just because I do it one way doesn't mean that a way you do it is incorrect. Alright, but if we get back to this proof, well, let's see. Now, if I'm looking at the red triangles, alright, notice what I have. I have side here, an angle here, because I just said angle 1 is congruent to angle 2, and I have a side. But remember, that in order for me to use, I can't use side angle side here because my angle's not in between the two sides. So what I need to do is I need to look at the red triangle. Pretend the blue triangle's not even there. If you look at the red triangle, notice that you have an isosceles triangle. So I can actually say that angle S is congruent to angle O. Angle S is congruent to angle O because I have sides here, so if sides, then angles. If sides, then angles. Because the sides of the isosceles triangle are congruent, the angles are as well. So I'm going to write if sides, then angles. Alright? And now if you look at the red triangle, okay, so triangle MRS and MRO, notice we can prove those two big triangles congruent by angle, angle, side. So I'm going to say triangle MRS is congruent to triangle MRO by side, angle, side. And now go back to and think about what were we trying to prove? We're trying to prove that R is the midpoint of SO. So therefore, I need to say that SR is congruent to OR. And do I have enough information to do that? Well, I just proved the two red triangles congruent. So because of that, I can say SR and OR are congruent by CP, CT, C. And because I've proven SR and OR are congruent, I can now go to my last step, which is proving that R is the midpoint, and I can say R is the midpoint of SO. And how do I know that? Because, well, it's definition of midpoint, or you could say midpoint implies two congruent sides. But for our purposes here, we'll just write definition of midpoint. I've proven that SR is congruent to OR, so that's enough for me to show that R is the midpoint. Alright, let's go on to number 6 and 7 here. Alright, so number 6 gives me a lot of information. So again, because I don't have a lot of room, I'm just going to draw my arrow over there. So what's it tell me? It tells me AB is perpendicular to BC. DC is perpendicular to BC, and it tells me AB is congruent to DC. And it also tells me that E is the midpoint of BC. Now, before you start a proof, always look at what you're trying to prove. Here we're trying to prove that angle EAD is congruent to angle EDA. So we want to prove that these two angles here are congruent to each other. Okay, so let's start our proof, and then along the way we'll figure out how we're going to do that. So what do I know? Well, let's take care of the perpendicular stuff first. If it tells me that it's perpendicular, I actually have to say that I have right angles. So I'm going to say angle ABE and angle DCE are right angles. All right, how do I know that? Well, that's what it means to be perpendicular. So if I can say if perpendicular, then right angles. Okay, so I'm going to go ahead and put my right angles in. Now, again, we can't actually say that those are congruent just because they're right angles. We actually have to throw in another step that says, okay, angle A and angle ABE is congruent to angle DCE, because all right angles are congruent. All right angles are congruent. Okay, now I can mark those two congruent. So what else does it tell me in the given? Well, it tells me that E is the midpoint of BC. So what does that mean? If E is the midpoint of BC, well, that means that I have two congruent segments. That tells me that BE is congruent to CE. And that's just what it means to be a midpoint. So for that, I can just write definition of midpoint. I'm going to do a lot of abbreviation there. Definition of midpoint. All right. Okay, now that I have these, now if you look, I have these two triangles congruent. So because I have them congruent, I'm going to state that. I'm going to say triangle ABE is congruent to triangle DCE, right? And that is by side angle side. Side angle side, side angle side. So I'm going to write that in. Now, the question is, why are we proving two triangles congruent when we're ultimately trying to prove that these two angles are congruent? Well, we're going to have to use our properties of an isosceles triangle here. Because now, because I've proven these two triangles congruent, that means all their corresponding sides and angles are the same. So that means that AE and DE are the same. So I can actually write AE is congruent to DE by CP/CTC. Well, how does that help me? Well, if you notice, if you look at this blue triangle up here now, the one I'm shading in blue, okay, I can use my isosceles triangle property that says if sides then angles. Well, if I've proven AE is congruent to DE, that means that angle A, or angle EAD, has to be congruent to angle EDA, because if sides, then angles. If sides, then angles. So I can say angle EAD is congruent to angle EDA because of if sides, then angles. If sides, then angles. Okay? Alright. Alright. Let's go to the next problem, number 7. Alright, this is number 7 is a tricky problem. let's go ahead and walk through it here. We have, first of all, it tells us we have a circle, and then it tells us QS is congruent to TR. That's all it gives us. So what I like to do first then is kind of really think about, what do I know? Well, I have a lot of radii here, and I know they're all the same. So I'm going to start by saying QP is congruent to RP, is congruent to PX, is congruent to PW, because they're all radii, so that means they are all congruent. And my reasoning would be all radii are congruent. Alright, so I have PX, PW, and then I have QP and PR. I know they're all the same. Now, I only have 2 triangles in here, so those are probably the 2 triangles I want to focus on proving congruent. Now, I know that QP, okay, I know that all my radii are congruent, so QP, oops, let me add another tick mark to some of these. So I know that QP and PR are congruent. Well, how does that help me? Well, if you see here, the given tells me that QS and TR are the same. So if you see, I can actually say that PS, that's this line right here, is congruent to TP, that's this line right here, by subtraction, because I'm taking the whole radii and I am subtracting this congruent part here. So I'm basically doing red minus blue, red minus blue. So I can say PS is congruent to TP by the subtraction property. Okay, so now if I look at my 2 triangles, I have a side and a side, a side and a side. Well, I also have an angle congruent. Okay, I know that these 2 angles right here are congruent because they are vertical angles. So I can say angle SP